Hello, we're Group 12 and our grand challenge is reverse engineering the brain. My name is Matthew Harmon,
My name is Caitlin Vo.
My name is Isaac McIntyre.
Hi, my name is Nicholas Webb.
and our topic is neurodegenerative diseases and their impact on the elderly population. With neurodegenerative diseases causing varying impairments to one's memory, coordination, and/or independence, coupled with the fact that diseases such as dementia are projected to double in scale from now to 2050, advancements in health technology is necessary to help resolve this global crisis. According to the World Health Organization, elderly people make up over 12% of the population and count as anybody over the age of 60. Despite that, with many neurodegenerative diseases occurring amongst the elderly, there's actually a very small amount of awareness when it comes to neurodegenerative diseases relative to the percentage of the population. This is why we developed NeuRegen as a solution to help fight against and bring awareness to these terrible neurodegenerative diseases.
NeuRegen is a regenerative brain therapy that uses a patient's own cell, nanotechnology, and AI imaging to rebuild damaged neural tissues instead of just slowing symptoms. First, skin or blood cells are reprogrammed into induced dopamine stem cells, then turned into the specific neurons that are lost in each disease, like dopaminergic neurons in Parkinson's. Similar, IBS-C derived neurotransplants are already in clinical trials and have shown survival, dopamine production, and symptoms improvement in Parkinson's patients without tumor formation. Next, NeuroRegen used nanocarriers plus focused ultrasound to temporarily open the blood-brain barrier and deliver these therapeutic cells or cell-derived factors directly into damaged brain regions, an approach supported by studies showing focused ultrasound can safely and reversibly increase BBB permeability and enhance nanoparticle delivery to the brain. Finally, AI-driven analysis of MRI and PET scans is used to monitor how well the new cells interrogate, detect complications early, and adjust dosing. Recent work shows that deep learning models can accurately track and even detect neurodegenerative changes from imaging data, supporting NeuroRegen's AI-guided monitoring component.
Our physical component is a 3D model of our solution, NeuRegen. NeuRegen works by regenerating damaged brain tissue using induced pluripotent stem cells, nanotechnology, and AI monitoring. It takes the patient's own cells and turns them into healthy neurons, delivers them across the blood-brain barrier using targeted nanocarriers, and allows them to reconnect broken pathways to restore memory, coordination, and brain function. The AI system continually analyzes scans to guide treatment and ensure the new cells grow and integrate correctly. This solution directly replaces lost neurons rather than just slowing symptoms, giving patients the chance to regain abilities lost in neurodegenerative diseases. Our solution, NeuRegen, is deeply connected to the engineering grand challenge of reverse engineering the brain. This challenge is about learning how the brain functions to help cure neurological issues. NeuRegen help with this by using stem cells and AI to rebuild damaged brain tissue. It also helps to form new connections or restore lost functions. This design uses engineering to repair the brain and cure neurological diseases.
The next steps would first be to find a more efficient way to administer this treatment so costs can be lowered for both patients and for firms producing NeuRegen. Since this research is still in the early phase, it would cost a substantial amount of money to derive these treatments. The first priority would be optimizing efficiency and resources so that it takes a short time to manufacture what is needed for these treatments, as well as finding a way to gather resources at a low cost. After this, parts of NeuRegen can be tweaked to help with multiple neurological problems or diseases, rather than just focusing on neurodegenerative diseases in elderly people. The technology used in NeuRegen can be used for more than just elderly patients with neurodegenerative diseases, particularly paralyzed individuals. Paralysis has to do with the death of brain cells responsible for movement, so this treatment could potentially help restore those areas of the brain that are damaged.